Hello, I am Mr. Fixit from ES Repair. Technology has come a long way since the first home computer. Today, a typical CPU speed is 4 gigahertz. Have you ever wondered where the CPU and the other components get their high speed? The PCI Express, USB, and memory all have faster speeds these days. But where does this speed come from? This is a typical motherboard for a desktop PC. Now, although technology has come a long way with faster and faster PCs, the technology behind it all has been around since the early 1980s, and it hasn't changed much. If you buy a PC today, it is still using the same technology. In fact, your TV, tablet, and smartphone also use the same technology. Would you be surprised to know that the base frequency of the PC is only 14.31818 MHz? If you look closely at the motherboard, you can see the quartz crystal next to the north bridge, where it is often found. It will have a marking indicating the frequency. Now keep in mind that this is only the base frequency. All the components that make up the PC do not run on 14.318 MHz, but are based on a derivative of this frequency. If you look next to the 14 MHz crystal, you will see an integrated circuit, or IC, called the Frequency Timing Generator, or FTG. It is also known as a frequency synthesizer. All the components from the CPU to the PCI Express to the USB all depend on this chip. The frequency is a series of on-off pulses known as clock pulses. Now this is not to be confused with a real-time clock. It has its own 32.768 kHz quartz crystal to keep track of the time of day, and it's isolated from the rest of the system. The FTG was first used in the 1981 IBM Model 5150 computer that used the 8088 processor. Here you can see the 14 MHz quartz crystal sitting next to the Intel's 8284 clock generator. The 8088 CPU's top speed was only 4.77 MHz. The FTG generates a range of frequencies from the quartz crystal. It can divide the base frequency, or it can multiply it, depending on the component receiving the signal. For example, if you were to divide 14.31818 MHz by 4, you would get 3.58 MHz. The frequency used for the NTSC color video modulation signal for TVs and monitors. Now, if you were to multiply the base frequency by 1.75, you would get 25 MHz for the Ethernet controller to communicate with networks at 100 megabits per second. This is the reason why the base frequency was chosen. It can provide the necessary frequencies needed for all the components in the PC, and it is widely available. The FTG provides signals for the CPU bus, the PCI bus, the memory bus, the USB bus, and so forth. It also provides signals for the PC speaker for BIOS to provide audio tones during boot up, and the audio controller to process digital audio. Now, many components operate at different frequencies. So, in order for these devices to communicate with each other, the FTG uses phase lock loop to synchronize the clock pulses to all of the components. The FTG generates the frequencies based on the CPU's bus speed. For most computers, you cannot reprogram the FTG, but on some high-end motherboards, you can reprogram the FTG as long as the CPU is unlocked. This means that the CPU speed can be changed. It's also known as overclocking, which is often done in BIOS. If you change the speed of the CPU bus, then the FTG will also change the speed to the other components to keep the system in sync. Some BIOS configurations will let you change the frequency of the individual components, but it is not recommended unless you understand the risks involved overclocking the system. No matter how fast a PC can process data, it is all based on a 14.31818 MHz quartz crystal and the FTG. They will provide a much more stable and accurate frequency than using a standard resistor capacitor or an inductor capacitor type oscillator. Now, the components, like the CPU, have multipliers to increase the incoming signal from the FTG to a much higher frequency. For instance, if the frequency from the FTG is 200 MHz and the CPU's multiplier is 19, then this will give the CPU a speed of 3.8 GHz. Well, this is how the CPU and other components achieve such high speeds. I am Mr. Fixit. Thank you for watching.